Welcome to question 5 of the 2013 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 5a we're asked to solve the equation 2 log 3 of 5 minus log 3 of 2 plus log 3 of x is equal to 2 for the variable x. So there's a number of different ways that you could go about solving this. But I'm going to aim to get the log 3 of x on one side and everything else over to the other side. So therefore our equation will be able to be written as log 3 of x is equal to, and you'd have the 2 there, but I'm going to write this as 2 times log 3 of 3, just so there's logs on all the terms on the right hand side. And we know log 3 of 3 is simply 1, so we're allowed to do that. And then we would have plus log 3 of 2, so plus log 3 of 2. And then we would have minus 2 log 3 of 5. Now in our next line we would have log 3 of x is going to equal. And one of the properties of logs is if you have a coefficient of 2 multiplying the log term, you can actually put it up as a power. So we're going to do that to this term and to this term. So that will give us log 3 of 3 squared plus log 3 of 2 minus log 3 of 5 squared. So on our next line of working, we're still going to have log 3 of x is equal to, and we have log properties that say that if we add two logs, we can multiply whatever's inside them, and if we subtract logs, then we can divide whatever is inside them, as long as all the bases are the same, which they are for this question. So we're going to end up with log 3, and then 3 squared is 9, and as we're adding log 3 of 2, we multiply whatever is inside the argument, so we're going to have 9 times 2, and then when we're subtracting these two logs, we're going to have 9 times 2, and we're going to divide whatever is inside them, so we're going to divide by 25. And now that we have an equal statement with log 3 on both sides, we can just equate the parts inside. So that will give us x is equal to 9 times 2 is 18 divided by 25. So that is the answer to part A of this question. From the examiner's report, we can see that 54% of students got full marks for that question and 32% of students got 1 mark. And the report goes on to say that many students solved this equation correctly. A disappointing number of students, however, could not combine all parts of the logarithms into a single expression. So that's an area for improvement for students in the future. For part B, we're asked to solve the equation 3 to the power of negative 4x equals 9 to the power of 6 take x for the variable x. So we're going to start by rewriting these with the same base of 3. So the left hand side is still going to be 3 to the power of negative 4x. However, on the right hand side, we're going to turn that into 3 squared is 9 to the power of 6 subtract x. And now we would have 3 to the power of negative 4x on the left hand side is equal to, and when we do a 3 to the power of and the power again, we actually multiply the two powers together, so we're going to have 3 to the power of 12 subtract 2x. So now that we have an equation with the same bases on both sides being equal to each other, we can just say that the exponents must be equal. So negative 4x must equal 12 subtract 2x. And then we solve that just as a regular linear equation. So we can add 2x to both sides and we'd have minus 2x is equal to 12. And then dividing both sides by negative 2, we'd find x must equal negative 6. So that is the answer to part B of this question. And from the examiner's report, we can see that part B was better done than part A, with 64% of students getting full marks and 23% of students making some progress on the question. The majority of incorrect responses involved 9 being equal to 3 cubed rather than 9 being equal to 3 squared.